Hey everyone, in this video I'm going to discuss managing and monitoring processes. Now before we move on any further, it's important to define what a process is. Basically, an instance of a program is what is referred to as a process. So a process is any program, application, or command that's run on your system. A process is created in memory in its own address space when a program, application, or command is initiated. Now processes are organized in a hierarchical fashion. Each process has a parent process that spawns it, and a single parent process may have one or many child processes and passes many of its attributes to them at the time of their creation. Each process is assigned a unique identification number known as the process identifier, or PID for short, which is used by the kernel to manage and control the process through its life cycle. When a process completes its life cycle, it is at that point terminated, and this event is reported back to its parent process, and all the resources that were assigned to it are freed and the PID is removed. Now several processes are spawned at system boot, many of which sit in memory waiting for an event to trigger a request to use their services. These background processes are called daemons. So if you ever heard the term daemons before, that's basically what they are. Now there are two types of processes. There are foreground and background processes. A foreground process is one that's run on your screen and needs input from the user. And a background process, it basically runs in the background, just like its name says, but it does not need user input. Now, running a foreground process, we can either go to a dashboard and open it, or we can run it from a command line. Now, when you run a foreground process on the command line, you cannot do anything else until it finishes. So as an example, there's a command on Linux called sleep that does nothing but just sleep depending on whatever amount of time that you give it. So if we do sleep 300, this is going to sleep for 300 seconds. Whoops, misspelled that. So it's just going to sit and do nothing. And you can see here, because it's a foreground process, it locks the command line until it's finished. So I can't run or do anything. Now, to stop a process that has been run on the foreground, we can use the command Control-C. So just press the Control key and then press the letter C, and that will send a sigint signal to the process and basically stop the process. Now I'll go later into what the sigint signal does, and I'll cover all the different signals that we can send a process. But just remember, usually if you want to get out of a command that's kind of hung, or just it's running and you just want to close it out, just do a Control-C in Linux, and that'll take you out and give you another prompt so that you can run different commands. Now, if you have a data-intensive task or any tasks that require a long time to complete, it is a much better idea to run that task in the background to avoid locking up the command line. Now, I'm going to run the sleep command again, and we'll just do it for 360 seconds. And you'll see once again the terminal's locked up because we have to wait 360 seconds for the process to end before we can continue running commands. Now we can actually, instead of sending the Control-C sigint signal, we can actually press Control-Z to send the sig stop signal to suspend the process. It doesn't actually stop the process permanently, it just suspends it. So press Control-Z, and you'll see that you're given a quick little message, and that's basically saying our process was stopped, and it's given a job ID. So the process is still alive. It's just stopped at the moment, so we can still do things with the process. We can start it back up if we wanted to, but basically when we want to reference this process, we're going to reference it with that job ID. Now, if you want to see all the current jobs that you have, just type in the word jobs, and you can see here our one job. Well, we've got another one. I actually ran this command before I started the video, but you can have as many jobs as you want, and they're each given a unique job ID. And you can access that specific job based on that ID. So if we want to start that process back up, we can just type in FG, and that means we're going to start it back up in the foreground, and then the job ID. So if we want to start this one, we're going to press 5. And you can see here, it's just basically saying this was the original command, and now you can see it's in the foreground and we can't do anything. Okay, so I'm going to just Control C out of that. And now if we have our command line back, and if we do jobs, you can see that job ID of 5 is now gone. So let me go ahead and create a few different sleep processes. So we'll do one for 400 seconds. Whoops. And what I'll do is will suspend that. Then I'll do one for 500 seconds. And then I'll press Control Z and suspend that as well. So now if we do jobs, we've got 3 different jobs at the moment. Let's say we want to start job 6 back up. But we want to, instead of bringing it up in the foreground, let's bring it up in the background. To do that, it's the same way we brought it up in the foreground, but instead of doing FG, we do BG, and BG stands for background, and then we provide the job ID. So if we do, 6, it's going to start this process back up in the background. Press that, and you can see it just basically telling us this one's starting up again. But if you notice, our command line is not locked up, so we can run whatever commands we want. And just to confirm that process is still running, we can type in jobs again, and we can see this one is still running. This one's running, the rest are still stopped. We can stop this one again if we wanted to, just by doing, we can bring it back to the foreground with 6, FG6. It'll lock that up, and then we can send it a sig stop. And then if we look at jobs, it's now stopped. So basically, if FG and BG are the 2 commands to start a process back up again after you stopped it, and then you just give it its job ID. Now, I showed you guys how to create a process in the foreground, stop it, and then move the process to the background. And we do that by just sending it a sig stop and then doing BG and then the job ID. But what if you wanted to create a process in the background from the start, so you don't have to do Control Z and then the BG command? We can do that as well. And to do that, all you have to do is the command that you want or the process that you want, and then you put the and sign. All right, so you can see our command line is still there. If we do jobs, we can see the new job we created that's running in the background. Okay, so I showed you guys how to, move processes from the foreground to the background. What I want to cover now is the different states that a process can be in. Now, the first state I want to cover is running. So that's pretty self-explanatory. So anytime you're running a process, it's usually in the running state, which means the process is either running, just as it is in the name, or it means it's ready to run and it's just waiting to be assigned to one of the system's CPUs. The next process is called waiting. So a process that's in the waiting state is waiting for an event or for a resource. Linux differentiates between two types of waiting processes called interruptible and uninterruptible. A interruptible waiting process can be interrupted by signals, whereas an uninterruptible waiting process are waiting directly on hardware conditions and cannot be interrupted under any circumstances. A stopped process, so the third state we're covering is stopped, is a process that has been stopped usually by receiving a signal, and a process that is being debugged can be in a stopped state as well. And I showed you guys how to stop a process by doing the Control Z and sending a sig stop. So this process is actually in a stopped state. Then finally, the last state a process can be in is called the zombie state. And that means the process has been completed, but its entry still remains in the process table due to lack of correspondence between the parent and the child process. Now, I want to show you guys how to actually monitor your processes. So the main command that you're going to use to take a look at your different processes and verify if they're in a good state and just seeing what's running on your system is the PS command. So if you type in PS, you're going to see all the processes. Now, you may be thinking, wait, do we only have 2 or 3 processes running on the system? Not exactly. So when you do PS, that's only going to show you the processes that the user that ran the command or the user that's logged in at the moment has started. So we only started the 2 sleep commands. We've got bash. And then if you notice, the PS command itself that we just ran is a process in itself. But let's say we log in as a different user. So let me pull this guy out. Actually, I want a new window. And let's switch to user 1. And let's say he does a sleep 400 and then just runs it in the background. If we do a PS here, you notice we still have the same number of sleep processes. That's because we can only see the processes that we created by default. Now, if you want to see the processes from another user, we can actually do PS-U and then the name of the user. So we do user 1 and we can see all the processes that he has running at the moment. Or we can do a PS and then we just do -AEF. I believe E is for all processes. F is for full format, and I think A is kind of similar along the lines as E. It gives us or shows us all the different processes. So if we run this, we can see every single process that's running on the system across all users, as well as root. So these are all the processes that are running on our system. There's a lot of output. So let me just scroll to the top and just explain what the different outputs mean. So the user ID, so this is the user that created or spawned the process. Then we have the process ID that we talked about. So each process that gets created gets a unique identifier, and that's what this process ID is. And then I explained to you guys that a process usually has a parent process that spawned that specific child process. So that would fall under the PPID, which stands for Parent Process ID. So in this example, this process right here was spawned by whatever process has an ID of 2, which is this guy. So this guy is the parent process to this guy. And if you notice, we have this process. So this is the init process, which is the first process that gets loaded. So this is like the parent of all parent processes, which means he doesn't really have a parent process because he's the first process that gets initialized. So he just has a parent process ID of 0, which there's no actual process ID with that number. A few other things to take note of. So this is the command used for that process. I think everything else, for the most part, isn't that important. We also have the time that the process was spawned as well, right here. Now, the next command I want to show you to monitor processes is the top command. And this is a really valuable tool, as what it does is it automatically refreshes every 3 seconds, I believe, by default. So it's continually showing you the processes in real time so that you don't have to keep typing in PS over and then running it again and then running it again. And by default, it sorts all the processes by CPU utilization. So the first process that you see is always going to be whichever process is taking up the most CPU utilization. So if you're ever troubleshooting any issues like your computer is just slow, things are getting bogged down, things aren't working properly, it's a good idea to check the top command to see what processes are taking up the most resources. And top is a very powerful command because it allows you to sort processes by any field. So we can sort it by CPU, we can sort it by memory, we can sort it by any value, and it's going to sort through it just fine and show us whatever we want to do. It also includes a few other, informational stats like memory utilization, load average, and things like that. Also the total number of processes, as well as it shows you the different states or the counts of number of processes in each different state. So we have 1 running, 244 sleeping, 3 stopped, and 0 zombie processes. So top is a great tool. Definitely keep that in your pocket. Yeah, you're definitely going to be using that a lot. All right, and so I talked to you guys earlier about sending signals to processes, and there's actually quite a number of signals that you can send to a process, and the way you send a signal to a process is by using the kill command. Now, I know you're thinking, oh, because it's called the kill command, it's used for, terminating applications. And that may be true, but the kill command can do more than just stop applications. It can send a whole bunch of signals that aren't related to terminating applications. I think the reason they just called it kill is because most likely you're going to be using that command to actually stop and terminate applications. But just keep in mind that you can actually do and send various other signals as well. So to see the signals that you have in your arsenal, just type in kill-l. This is a list of every signal that you can send to a process. Don't worry about learning all of them. I'm just going to cover the main ones. So the main ones you want to focus on are sig-up. So this is the hang-up signal, which basically causes a process to disconnect itself from a closed terminal that it was tied to. And it's also used to instruct a running daemon to reread its configuration. So that's a helpful signal. The next one is sig-int, and we already did that when we were working with the sleep process. When we ran the Control-C, it basically just interrupts the execution of a process. And once again, you do that by pressing Control-C. Then we have the, so sig-int, that's the second one right here. So after that, we have the sig-kill. So that's this guy right here. Sig-kill immediately kills a process. And this isn't like a nice way of killing. This is just straight up just cutting it off. It's not the most elegant way of doing it, but if you find a process is hung and not responding whatsoever, you're going to want to send it a sig-kill signal. The next signal I want to cover is sig-term. That's this one right here. And this is the default signal that if you just type in kill and then a process ID, it's going to send this signal. And this is a soft termination. So it's a more elegant form of sig-kill where we're not just straight up just, killing a process. We're basically asking the process nicely, can you please stop yourself? And that'll give the process an opportunity to gracefully shut down so that you don't corrupt any files or anything like that. So whenever you want to stop a process, I recommend you starting with sending a sig-term, and only if that doesn't work should you fall back to sig-kill. Then finally, the last signal I want to cover is this guy, sig-stop, and I showed you how to do that as well when we were working with the sleep command. It basically sends a request to stop. So it's basically halting the process, but it's not, it's not like terminating it. So the last signal I want to cover is sig-stop, and I showed you how to do that when we were working with the sleep command. We pressed Control-Z to basically tell the process to stop, but it was in a state where we could technically start it back up whenever we wanted to. And remember, we do that with the Control-Z command. All right, so we've covered a lot of things up to this point. Let's go ahead and open up Firefox and let's play around with that for a bit. So we've opened up Firefox. Let's do ps-aef. And remember, there's a lot of output. Let's say if I just want to find my Firefox process, we can actually just grep for Firefox. So these are all the processes that are associated with this Firefox. The main one we want to be concerned with is 6405, because the rest of these guys over down here are all child processes of 6405. And you can see because the parent processor ID for all these guys are 6405, which is the process ID of this guy. So this is the main process, and if we want to send a kill signal, or at least gracefully kill it, we can just type in kill, then the signal number that we want. And remember, the default is going to be the -15, which is a sig term, which means we're going to ask Firefox to gracefully close. So if we do kill and then provide no other arguments except for the process ID, which is going to be 6405. We can do that. And you can see it killed the Firefox process. Let's open that back up again, and I'll show you how to do the kill-9. So if we do a ps-aef pipegrep Firefox, so the process ID is now 6563. And remember, because we killed the previous process, when the new Firefox process opens up, it's going to get a unique process ID. So it's not going to be the same number it was before. So if we want to do just a straight up sig kill, so this is basically killing the process in a non-graceful manner, just do kill-9 and then this process ID. So 6563. And once again, we've killed that process. So that's basically how you send signals to processes. Definitely get comfortable with this and practice this as much as you can. The next thing I want to show you is, what if we want to quickly and easily find the process ID of a certain process? So let's say we open up Firefox, but we don't want to have to, look through the ps command. Well, there's a couple of commands that we can run to quickly and easily get the process ID of, say, a Firefox or any other application that you're using. And those two commands are pgrep. So you type in pgrep and just the name of the process, and it's going to tell you the process ID. Or you can do pidf and then the name of the process, and it's going to show you, pidf actually shows you the ID of all the processes, not just the parent process, but the child processes as well. And on top of that, we can also do pkill. So this is kind of like doing pgrep, except it's used for sending kill signals, but we don't actually have to use the process ID. We can just put in the name. So if we do that, it should kill the Firefox process. I will say definitely be careful with this. If you have a lot of Firefox processes, and you only want to kill one, or if you have a lot of instances of a certain application and you only want to kill one, remember, this will kill all of them. So that's why it's always better to get the specific process ID and just run a basic kill command versus using pkill. But I did want to show you how to use that just in case. All right, and the last topic I want to cover in this video is it's basically about process priority. So all processes have an attribute referred to as niceness. Now, the niceness determines the priority of the process, and the niceness can be a value between -20 and +19. And most systems, when you start a process, use the default niceness of 0. And basically a higher niceness means it has a lower execution priority. Okay, so that means the higher the niceness number, the less prioritized that process is. So other processes are going to be more likely favored over that one. So if you want a process to be treated with high priority, basically it's a very important process, so any CPU cycles should be assigned to that whenever it can. You want to make sure it gets a lower niceness value. And remember, the range is between -20 and +19, so -20 means that's the most prioritized it can possibly be. Okay, so if you want to check the niceness of a specific process, use the ps command, but pass in the e and l arguments. And I'm just going to do a more just so we see the first few lines. I just want to show you this top line. So this is the niceness value. So you can see here, this is the default 0, 0. This is -20, which means this is a very important process. But let's go ahead and use the nice command. So if we do a nice, actually, let me first show you, if we do top, okay, so we're running top, and then on this window, I'm going to do a ps-aef pipe grep top. Actually, let me do an el. You can see the niceness value of a 0, okay? So if we instead do nice, we want to do sudo first, actually. Sudo nice, then the nice value. So you want dash. This doesn't mean negative, by the way. This is just means that this is the next option or parameter that you're passing into the command. So if we want to give it a nice value of 2, this is positive 2 again, which means that it's going to be less prioritized than if we had run it with the default niceness of 0. We then put in the name of the command. So now it's running, and if we run this command again, you can see it now has a niceness of 2. And if we want a negative number, we put in 2 dashes. So if we want -7, it's going to be --7 in the name of the command. And if we check the niceness now, it should say -7. Now, what happens if we want to change the niceness of a already running process? Because the nice command only allows us to tweak the niceness of a new process that we're about to create. To change the niceness of a pre-existing process, we use the renice command. So it's going to be renice. Then it's going to be the new nice value that you want to give it. So if we want to change this to -19, we'll say -15 to make it a little more prioritized. Then we give it the process ID, which is going to be 6887. That's this guy right here. And remember, we need to root privileges. And now, if we check this, you can see that the niceness has now changed to -15. So that's how you basically change the niceness of a process. It's not too difficult. I don't know how often you're going to be doing that, but it is something to note. One other thing I want to cover real quick is if you want to see the default niceness set on your system, just type in the word nice, and it's going to tell you what the default value is. So our system is currently using a default value of 0, which I think all systems use by default, but you probably can tweak that to be another value if you did want it to be. But if you're just starting out with Linux, I wouldn't, bother, messing around with default settings like that. All right, guys, that's all I had for you. Hopefully you guys found this video helpful.